Welcome back to part 2 of this STK4191 stereo amplifier build. Now, before I get into assembling the rest of the components on here, I did actually spend some time last evening reverse engineering this back to a schematic. So here's what we've all been waiting for. Let's see how this thing works. This is the entire schematic broken up into 3 sections: the preamplifier, the power supply and the power amplifier. Now, it is printed rather small, yes, I know. I will put a link in the description at the bottom of this video to where you can download and look at this in, I believe it will work in 300 dpi, so it'll be a fairly large JPEG that you can look at and you can zoom in and out to your heart's content. So we'll go through section by section here. It's not that overly complicated. And we have the input. Now, I've only drawn the left hand channel of the preamp because the right hand channel is exactly the same, hence the notation of R103 and C102 for example. It means that on the other channel it will be C202 and R203 respectively, even though the part numbers are not marked on the silk screen of the board. However, this is supposed to be an NE 5532. They've provided a UPC 4558, which is an old NEC part. But NEC don't make the part anymore, obviously, so it's just a Chinese knockoff like everything else these days. So this is the first amplification stage here. It's going through a RF filter. I mistakenly said that the resistor coming off of here at the non-inverting input is for setting impedance. Well, it is, but it's more of setting the bias of the input stage. So that's what that resistor is actually doing, setting the bias of the input stage. Here is the negative feedback loop, so you can calculate the gain by taking 47k and dividing it by 5k6, which off the top of my head I don't know what it is. Okay, so we got 47 divided by 5.6 plus 1. It's running at a gain of around about 9, we'll say 9. And the output of that is fed through this resistor, which is a 560 ohm resistor, before it reaches the next stage. Now, they usually put at least a 100 ohm resistor in between two high gain, from a high gain op amp stage into the next op amp stage, to prevent the first one from oscillating or going into the onset of oscillation. So that's what that resistor is for. You don't really need to have a bypass cap here. You can if you want, but it's unnecessary. So moving on to the next stage, after the 560R, we've got this 5K6, which is going into the non-inverting input of U2 here, which is also supposed to be an NE 5532, but again is a UPC 4558. And this resistor again is setting the input bias of the non-inverting input, as well as setting a low impedance as well. Here's a 27k feedback resistor going across the output. Now here comes the interesting part. Now, I believe I've reversed engineered this circuit correctly. I went through it 5 times and drew it out on paper before finally coming up with this. What they're doing is there's no actual, like our first stage over here, there's no resistor here in the earth path. What they're doing is they're passing the signal now from the output through a 4.7 nanofarad capacitor and a 470 ohm resistor into the counterclockwise position, which is the first pin on the pot. So when you see things like CCW counterclockwise, Usually there's an arrow pointing, but it means that the pin closest to where the word counterclockwise is pin 1 of the pot as you look at it from the front. Pin 1, pin 2, pin 3, so it's that pin there. So it basically means that's you're mounting this resistor to the counterclockwise position. Conversely, the same when you see CW, you're mounting this circuitry, where the CW part is, on pin 3, or the pin closest to the clockwise position, which is, in the case of this pot, pin 3. So that's how you determine the difference. Anyhow, back onto this. So basically the center wiper of the treble pot is being put in the position of where, on this particular stage, the 5K6 is here to earth. It's actually putting this resistor in that network. So effectively it's controlling the amount of gain on this op-amp stage using the high frequency. So the more boost you give it in treble, the higher the gain the op-amp will be. Conversely, the less boost you give it, the lower the gain of the op-amp will be. Technically speaking, the bass pot is also included in this negative feedback loop of that second op-amp. But really, we're getting control because it's coming through this resistor 1K here into the counterclockwise position of the bass pot, and when you rotate that, the center closest to clockwise, you're going to get boost. So it's technically going to feed it back into that first op amp here, or the second op amp stage I should say, into its negative feedback loop. And conversely, when you cut, it's going to provide a high pass filter rather than a low pass filter. So you can basically consider this an active band axle circuit. That is, you put the tone control network in the feedback path of an op amp. So it's actually controlling the gain at the boost and the cut frequencies. Conversely, and that way you get, well, 1-to-1. That is, the voltage that comes into it is what the voltage is when the tone controls are flat. That is, the voltage coming into it is going to be the same as the voltage going out of it. There is no change, because passive band axle circuits have the tendency to have quite a fair amount of decibel loss, so you need to add an extra preamp after the network. And then it's just going through a 2K2, a 10 microfarad now. First error I found on the board is one of these is backwards on the silk screen. In other words, I connected the negative to the 2K2 instead of the positive on one side of the one channel. Not that it matters, right, because you're just passing an AC signal, but yeah, they've just like slapped the component on their CAD thing down onto the board and then haven't bothered to rotate it 180 degrees to get it the correct orientation. However, yeah, it is what it is. You can always change that. This is the power amplifier section. They've actually done it backwards in the circuit. They've started at pin 18, which is one input for the right channel, from the left preamp. It's just where it ended up on their board when they were routing it. I don't know why. They've basically directly copied the data sheet for this, for the application. All they're missing is, well, an inductor and parallel resistor, so the output should have actually come off of, I think it was a 3.7 nanohenry, millihenry or something like that, microhenry, I have to look it up, I can't remember, and a 4R7 resistor there. And down over here you'll find something very interesting. This is going across the output pin of the IC here, and there's the feedback resistor of 56K going into our frequency roll-off stage here, which also controls the gain. I don't think I've actually calculated the gain on that. They've got this set to a gain of 101 for some weird reason. And anyhow, like, there wasn't enough gain on the preamp. I'd have to do some tests and see if that was way too high, but this is actually on the data sheet as a 560 and a 100 microfarad. Pin 15 here, and conversely over on this channel here, which is pin 5, we've got a 2K2 and a 2K2 voltage divider network, and both are actually connected physically together. And we've got a capacitor here going to the output in between the voltage divider, and a capacitor here going to the output of the other channel on this resistor divider. Now, this capacitor here across the output and here is actually known as a bootstrap. What it is supposed to do is change the impedance of the amplifier, and when applied deliberately like it is here, its intention is to increase the impedance of the amplifier, not decrease it. So there's a whole different video here on the principles behind bootstrapping an amplifier, which I'm not going to go into, but that's what this circuit is, and the one on the other channel, it's a bootstrap. So that's the power amplifier section. There's only a few differences with pins here. We've got these two 1K 1 watts. I've shown them as 1 watt, so the data sheet requires 2 half watt. I think they've used 2 watt. It doesn't really particularly matter in this instance. I'm not sure, without looking at the data sheet, what these two are for. It goes through a 10 microfarad capacitor to earth. The only interesting thing is this was not on the data sheet. There is no 100 microfarad capacitor going to earth between the two bootstraps and pin 4 here. I don't know what they put that there for. The data sheet's also incorrect, and glad that they actually got it right. This line here between pins 14 and pin 9, they marked on the data sheet as also VCC. They should have been marked as VEE. But luckily, the Sri Lankan dude that actually looked at the data sheet and basically copied it almost word for word, realised, oh no, this should be the VEE line, so that should be going to the negative rail, not the positive, otherwise you're just basically shorting the thing out. So I've got this set to run on plus and minus 35 volt, which should, these ICs are supposed to run at 55 volt plus minus maximum, and plus minus 50 if you're going to power it into 4 ohm loads for producing 50 watts continuous output. Now, running it at plus minus 35, yeah, it'd be probably like more like 35 to 40 watts. But because these are knockoff chips that any Sanyo have never made for ages, that's yet to be proven. But in my testing of this, when I finish constructing it, I'll only be running it on plus minus 25. It should still work, but the output power will be lower. And finally, the power supply selection. Yes, they've got 4 1N5392s. Now these are 100 volt, 1.5 amp maximum diodes. So I reckon these are going to be underrated for the job. Anyhow, so we got all these 4 diodes connected to form a full bridge rectifier. I've got to stop saying that. Electro Boom, thank you for giving the rest of YouTube the incorrect terminology for the thing. It's full wave bridge rectifier. Anyhow, that just become a catchphrase of his now, so he's actually the rectifier. Anyhow, we've got an AC input of 25025, and which after rectification should give us plus minus 35 volt, but it's more probably likely to be more closer to 38. That's going through to 4 700 microfarad filter capacitors, and that's the 35 and minus 35 are tapped off each end of those filter capacitors, and the common or 0 volt rail is taken off the center of the caps and the center trap of the transformer. Then we're going through 1 watt 1K resistors on either side into these two xenodiode basically regulators, what they're doing is they're clamping the voltage down to provide plus minus 15 volt for the preamp. So these are both 1 watt devices, and as I said, at 1 watt you're looking at a current draw of 70 milliamp to produce 1 watt dissipation through these devices. So the preamp shouldn't run any higher than 40 milliamps. But yeah, I wouldn't use the 1/4 watt 1K resistors that they provided. I'd change them to at least half watt, if not 1 watt. And that's it. That's the power supply. They've just got a couple of 100 microfarad capacitors on the 15 volt rail here, and in common with earth here, to filter the output of the 15 volt rail, and that's it. There's nothing more to it. It's as simple as it comes. So now we've spent all this time looking at the schematic, which I said will be available in the description as a link, so you can go look at it. Let's get into finishing off construction. And it's the next day, and something totally unrelated here. Look at this shit. A few days ago, this tree, it looks like a complete tree, fell over and fell on this poor trampoline here. It goes all the way back over there somewhere and comes all the way along to over there. That's got to be a good 60 to 70 meters worth of tree there, and it's just this trampoline completely f***ed it. Look how long it is. Goes all the way back over there somewhere, and of course it's heavy as f***. I'm going to need a chainsaw to cut this up. I believe this is just an ordinary gum tree, not sure what type of gum. It's fairly heavy. And here's the other end of it. It's actually part of this tree here. So I'd hate to see the rest of this fall over. But yeah, you can see at the base of the tree here, it was like a 2-branch trunk. It's pretty rotten, so it's just rotted out over time and fell over. Yeah, so this is going to be fun to clean up. Wow. Yeah. From where I'm standing now, that looks like at least 60 meters away to the top. Yeah. Absolutely fun. Lucky this tree wasn't anywhere near the house and decided to fall on it. That would have been disastrous. Anyway, I just thought I'd share that. It's totally unrelated, but look at the way it's just bent the out of that trampoline. Anyway, back to some electronics. So anyway, I'm going to continue on with the construction of this STK4191 amplifier. Actually, when you order this, you can actually go with either an STK4101 up to a 4191. There's like about, I think, from memory, 10 different ICs that will fit on this board. You don't have to change anything except the supply voltage. And speaking of supply voltage, I was right when I said there's 10 of them, but for the last one, which I'm using, they reckon the AC transformer voltage should be 28028 at 3 amps. Now there's a clue. And the expected DC voltage is plus minus 35 volts. Well, that's wrong. It's going to be more closer to 43 odd volts after rectification. But here where it says 3 amps, yeah, that's a bit of a worry considering those rectifier diodes are only rated at 1.5 amps. Yeah, I was close. It's actually more like 39.5 volts. Nowhere near 35. Anyway, so these are all the STK modules that you can use with this kit, and you just tell the seller which one you want. The lowest being a 4101, which requires 12012, and the expected output is 6 watts. Then there's the STK4111, yeah, which is 10 watt, up to 50 watt. So I'm using apparently the 50 watt version. Now I mentioned there was a couple of electrolytic capacitors that have been drawn incorrectly on the silk screen here, and I've actually marked with a whiteboard marker which one it is, or which ones they are. One was the 10 microfarad capacitor on the right hand channel, or it could be the left hand channel, I'm not sure which, but on the channel next to it is the other way round. So in this case they're going through a 2K2 resistor here to the negative portion of the 10 microfarad, and over here they're going from a 2K2 resistor to the positive portion of the capacitor, so both are different. So it was a toss up which way round to do it, so I just went 2K2 to positive, so I'm going to reverse that one round in circuit. There's also an 100 microfarad over here which is in the right hand channel of the power amplifier. That is this 100 microfarad capacitor here. The positive is supposed to be according to the data sheet, it's supposed to be going towards this 560R, which on this side it is. It's correct on the silk screen. However, the capacitor I marked on the circuit board there is this one, so this one's the one that's backwards, and I don't think generally speaking it matters which way round you put it, but I'm going to put it the way round that it's supposed to be according to the other channel. I'm also going to change these two 0.22 microfarad capacitors here and here, which are in the base control section, because as it's a low pass filter you don't really need to be using electrolytics. I don't know why they're using electrolytics, so I'm going to use, well, these Chinese brand of MKTs. They're more like polyester than anything else, but yeah, that's a 0.22 microfarad at 63 volt, I believe is what the 63 means. So that's what I'm going to replace them with. They're actually what you should be using. Yeah, I don't see the need to be using electrolytics there. It's just kind of pointless. So I'm going to get going. I'm going to plug a soldering iron in and start soldering in all the capacitors and stuff that I need to solder in. And I'm not going to film it, but when we come back it'll be almost complete when I get up to the stage of actually mounting the IC, the main IC, because I've actually got to measure the heatsink for it. Also went out to JCar and got a few more parts, as you do. Some ribbon cable. Now I'm going to mount the pots off of the main circuit board so I can have control on the front panel where things go, and this stuff is quite handy to use because one, it's color coded, and two, well, they stay together. So that's just a rainbow ribbon cable, nothing exciting there. I couldn't get a 50k logarithmic 16mm dual gang pot, so I went with this 24mm one instead. And that's to replace the incorrect pot in the kit. I'm going to use the other three pots that are in the kit, which are actually correct for where they go. But again, I'm going to have wires coming off of them. But that leads me to another thing. I managed to get 3 pot nuts and washers for a 16mm pot from JCar for free. So, no, I didn't steal it. The guy said you can have them because they were supposed to be selling these in packs of 12. He's been asked this question before. They don't exist, so he just gave me 3. I said, yeah, there you go, don't worry about it, paying for it. So that's the plan for today, is to start doing some soldering. So I'll come back when I'm up to the stage of mounting this IC. Okay, a short time later, about half an hour, there we are with all the crap capacitors that they've chosen soldering on. Some of the leads are very hard to solder to. They're just second grade pieces of shit capacitors. But at least they've used Nichicon capacitors for the filter capacitors. That's well, slightly interesting. Anyhow, I've replaced those 0.22 microfarads with these, and I've also swapped the polarity of that capacitor and the polarity of I believe it was this capacitor here. Yes, it was. And I had to get creative with this one over here because these resistors are now in the way, so it's sort of like at an angle before it goes in the board, but yeah, whatever works. Right, so the first thing to do is I'm going to connect this now up to a power supply as it is before I go any further, and just make sure that the correct voltages when I run it at plus minus 25 are where they should be, and that we've got the correct 15 minus positive voltages on the ICs before plugging anything in, and then I'll move on to the IC. Also, before I forget, it might be a good idea to join these two earth connections together. Probably should have done this when the board was flat. Right, so they should be electrically joined now. Cut off the end. There we go. So now both ground planes are joined. Anyway, back on to testing this thing. I need a good place for 0, which I haven't found yet, which would be on the cathode. Now the anode of this 15 volt Xenon will do. Okay, so now I'm going to wind up my voltage to, I'll go straight to the 25 volt, I guess, which we're almost at 25, yep, round about there. And I'm going to turn it on and see if anything goes bang. Well, it shouldn't, there's only passive components there. No, nothing went bang, and we've got a current draw currently of 20 mA. Alright, so I'm going to measure across pins 4 and 8 of each IC, 8 being positive, 4 being negative. There should be 30 volt there. Select the right scale might help. And according to this is only 22.5, but okay, that's okay. And this one also 22.5, and well, across the supply we have 51.8. So with that across to 0, got 24 volt. Okay, so the voltages look alright. Just trying to see how I can get to the large IC. Of course I put the schematic underneath the power supply, didn't I? I want to look at pin 14 and 9, which has one of the 1K resistors coming off of it. I believe is that resistor there, and pin 11 or a 100 ohm resistor, which would be that one. Yeah, we've got 51.8 across those points too, so I know that the IC is getting the correct VCC and VEE voltages conversely. Okay, now I need to think about putting the IC in. Now, in case anyone's wondering, how is this isolated from the heatsink? Well, this isn't metal because it doesn't actually conduct. So this is actually isolated from the rest of the IC, but allows heat transfers through it like all the STKs do. This is not any metal that I can tell. I think it's actually a plastic. In fact, I think you find it is a plastic. Looks kind of like a plastic. So we know that that's going to be electrically isolated, so there's no worries there. You don't need any form of isolation between the heatsink or the device. Now, the thing to do right now is figure out how I'm going to mount it to that damn thing. Okay, so I've worked out the hole centers are 70 millimeters apart, which just gives me enough gap there to get a 2 millimeters hole in there, 3 millimeter tapped threaded MK3 screw. Now, the actual placement of it on the heatsink. Now, the heatsink's actually going to make contact with the PCB. There's no way around that. Yeah, so I've got not much real choice there. I was hoping I could have it off the back of the board like that, but unless I can refashion these pins a bit, which I probably could, to give me an extra, at least, well, 3mm. However, if I bring up the amplifier module a bit and then pull it backwards before soldering it to the board, I can actually mount it directly to the heatsink first, and I've marked roughly where the centre of this hole has got to be on the IC, and it gives me just enough lead length at the other end to solder it to the board. So what I'm going to do is I'm going to draw a straight line roughly where it's got to be, and I can drill and tap those holes. Okay, so I've worked out the hole size needed is 2.5mm for the tap. Let's have a look at my enormous penis. Those holes line up pretty damn good. So I'm just going to carefully start bringing the tap in. Seems to be threading nicely. Alright, that's all the pins of the IC soldered. Board's not exactly straight. It is at this end but not that end, so I'll see if I can just make that little bit better. At least when it's mounted in the chassis, the heatsink will be nice and solid. The board, once it's screwed down, will be nice and solid, but there's still going to be a lot of movement. This is what you get with cheap, crappy Bakelite boards. I'm going to put a bit on there. I'm going to spread it around with the tube. Don't have to go too mad with it. That should be enough. So that's what the module looks like when it's almost completed, apart from the fact there's no pots on there. But as I said, I'm going to wire off wires to the pots, which I'll do in a minute. But first I'm going to do a power on test with both the ICs installed. I've already done the micro PC 4558s and the STK is in there. So I'm going to do a power on test and, well, check what's actually at the output. Okay, I've got it hooked up to the power supply now. I've got a couple of fly leads connected for the outputs here. And I'm going to slowly wind the voltage up. This is a power on smoke test, keeping an eye on the current, and if the current suddenly starts shooting up and the voltage stops increasing, I know there's a problem. So we turn it on. Nothing yet because we're at 0 volts. Slowly wind it up, watching the current, and I'm now at 1.1 volt, 2, nothing unusual yet, 3, 4, there's a little jump there to 20 mA, then it dropped off again, back up to 20 mA. We're at now 10 volt, current's dropped off again. We're at 12 volt, this is plus minus 12. 13, we're at 20 mA. 15, still at 20 mA. 17, still at 20 mA. The current might start increasing a little bit further after this once these Xeno diodes actually allow clamping to power the preamps. So it's jumping up to about 30 mA now. We're at 22, so I'd say the Xeno diodes are now allowing the correct voltage to go through to the op amps, and they don't appear to be getting hot. The main heatsink's not getting hot. We're at 22, 23, now we're at 25, and it's remaining constant at 30 mA. Okay, well, I've got all the potentiometers wired in with nice rainbow coloured wire. Yes, it looks messy, and it's probably harder than it really is. It's just more awkward than anything else. It took me an hour. It can be done. It's just, yeah, a pain, but as long as it's wired the same way at the other end, it doesn't really particularly matter. Now I've got everything set up here. I've got the DSO hooked up to the output of the left channel through a dummy load at the moment. Got 850 millivolts going into the input. Thing is off, and I'm going to, and I've also got it hooked up to a ×10 probe, so any voltage output on here will have to be multiplied by 10. I've got the voltage set to 0 again. I'm going to turn the load on, slowly increase the power, because now we're into a load, and see what happens. So we're at 22, 23, 24, 25.3, that's close enough. At 30 mA, that's perfect. Now I'm going to slowly increase the volume control. Well, it seems to be clipping badly. All I did was just rotate it. So I'm not sure why it's clipping that bad. It shouldn't be. Something seems a little bit funky here. Okay, got the probe back in ×1. Right, well, that is an output on the scope, but it seems to be interfered with the volume control, and it shouldn't be. Now this is what I'm not quite understanding here. We're getting a gain increase and decrease with the treble control, not much. A little bit of a decrease with the bass. So yeah, the preamp stage is working, but I'm not sure what's going on with this volume pot. It shouldn't be doing anything. Well, it shouldn't be doing that. So I'll disconnect the input. Well, nothing happens when I rotate it full. So that's strange. Alright, I'll swap over to the right hand channel. Okay, so I'm connected up to the right hand channel now. And interestingly, the volume pot is not doing the same thing, but I haven't changed the load on the output yet. Okay, I've changed the load to the right hand channel, and exactly the same thing. When the amplifier has the dummy load on it, it does that strange thing. So I'm a little perplexed at the moment. Really perplexed. I'm not sure what's going on here. Which means we're getting 8.72 volt peak to peak out of the preamp. Okay, that's not too bad. But I'm still not sure why it's doing what it's doing. It's kind of strange. That's really affecting the preamp badly. Okay, alright, it just seems to be clipping way too early. So, voltage for division. See, it's clipping rather badly. And that's odd because I'm only getting about 1.6 volt out for it clipped. Well, I know it's working as an amplifier, but just not very well. We are drawing 1.3 amps, so that, well, we were. There it goes. That bridge rectifier is not going to be substantial enough. Okay, nothing I seem to do seems to take what I think it should take in time. Everything seems to be just taking way too long. The thing should just work, not screw me about for hours on end, because I don't really have time for this. Now I'm getting an output voltage of 5.27. That's really odd. We're at 14 peak to peak. I'm just wondering if the supply voltage is too low, so I might just carefully wind it up a bit. It's at its max. It's yeah, it's not. Okay, the conclusion I have is the supply voltage is not high enough to test this properly, unfortunately. So, I know it is working, vaguely. I'm not liking it one bit. Kind of a pain in the ass and a waste of my time and money. So I'm probably not going to use it. I just don't have any way of getting anywhere near close to 40 volts. I reckon that's what's going on. When it starts trying to work as an amplifier beyond a certain voltage, it just starts distorting badly because it's got no more power. And this bridge rectifier, yeah, that's not going to sustain this amplifier for very long. It's just absolute crap. I mean, it's alright up until there, and then it just shits itself. But up to that point where we're drawing an output of 15 volt peak to peak, we've got a current draw of around about 800 mA. So we've got 14 volt times 0.8. That's about 11.2 watts at output power, and that's considerably loud, by the way. So for it to be at the, I want to say 9 o'clock position on the pot, to get 10 watts out of it is pretty good, but I just don't think there is enough power in this power transformer to this power supply, I should say, to work. It needs well above 35 volt plus minus to work correctly, but it is working, and the heatsink is warm to the touch, but it's not overly hot, so yeah, it is what it is. Now as soon as I start playing with the bass pot, then it shits itself again. It's like it's going into parasitic oscillation or something. And then, yeah, I don't know why it's doing that. Then it stabilizes again. So, if I drop the voltage now, or the volume, it stops doing it. But I can see that I've got no control over that. That's with the bass full, so that's not going to work too well. Oh, that's with the treble full. And action of the balance. Yeah, it's pretty much doing what it's supposed to do. Overall, am I impressed with the quality of this? No. Am I impressed with the performance? Well, if I had a much higher power supply, I probably would be, but at the moment, no. So, really, for the fact that in this test, I can't even put the bass at maximum without it shitting itself. So I can't even test an output into a speaker because I definitely do not want that going through a speaker driver. That fine, but not that. Even if I lower the volume to nothing, I mean, right there is where it's fine. And then it starts breaking up as soon as you just slightly increase it. So I think the main issue with this at the moment is there's probably a little bit too much gain on the preamp. and not enough voltage to sustain the power amplifier. So unfortunately I'm not going to be connecting any speakers up to this to test it because I don't want to damage them. But yeah, that's going to be it for this video. Yeah, I'm not impressed. I need a much higher power supply. If I had the right transformer it would be alright, but I don't. So anyway, I'm going to end this video here, and if you enjoyed it, I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.